Am I audible now? Students, please confirm. Am I audible?
Yes, sir.
Yeah. Okay. Right. So in the last class, we have seen the visualization of different plots using the advanced concepts. Right. Let's continue to it. Then let us see customization of the Matplotlib features. That's what configuration and then style sheets. Basically, when you import the Matplotlib, you'll get certain the style features. And then as I told you, by default, you'll get the blue color. And then line shape is little thinner. All right. So we have seen basically the class have this kind of a histogram. You can just look at this histogram. This is by default. When you without you applying any styles and then features, you'll get this plotting. If I just draw the histogram on a normal distribution of the points x from 0 to 10 between, then if I take 1,000 points and then how it is normally distributed, then when I draw a histogram on the normal distribution, you'll get this chart. But you can see the features. I'm talking about the features. Now you can observe by default, this histogram is in blue color. And then every step is in a black edge with a black edge, right? And you can observe there are tick marks in the directions. You can see the bottom, you have a small ticks, but they are above the spine. This line is called as a spine with the x-axis I am talking about. This x-axis is a spine, and you have a small ticks on every point. So they are above the line, right? Similarly, you can see here in the left side on y-axis, there are tick marks, 1, 2, 3, 4, 5 ticks, right? These ticks are inside the image, isn't it? And you can see on top, you also have a 5 ticks, 5 or 6 ticks. 1, 2, 3, 4, 5, 6, 7 ticks. All these ticks are the top, these ticks are shown inside the image. Similarly, in the y-axis right side, you can see the ticks are clearly visible, isn't it? But we can change or we can customize as per our requirements. Okay. So sometimes this is not sufficient. If you wanted to draw the two histogram on the same image, so it is not sufficient, or it is not good to have the same both the histograms in the same color at the same styles. So for which sometimes you may require to customize these default style settings, and then you can have a aesthetic view of the plotting. So for which what we do is we will be just changing the default settings with a routine called as a runtime configuration. This runtime configuration will help us to change the default configurations of the styles. What happens if I change the default configuration? So wherever you use the plotting routines, these changed configurations will be applied. That's what you have to be very careful when you are changing the runtime configuration. So for which what we do is initially we store or we save the default configuration into an object, and then we will reset as and when we required, right? Now here you can see plot customization. Usually when you want to do, what you will do by changing the different parameters, right? Now what it is, I simply took the classic style. By default, it comes with blue color with the black edges, and then spines are clearly visible. Spines means the borders of the image. The background is a plane, right? I did not mention anywhere the grid is applied. Now, I just wanted to in the background. So for which what you can do on the axis object, I just wanted to change the color. This color is what? Gray color. Okay, I just change the face color. This face color is also called as a background color. All right. So you can also call it as a background color. Okay. So basically this hexadecimal code indicates the gray color drawn from the RGB basic colors. Right. Now you can see what I did is I set the axis below is true. So when I set the axis below is true, so it will display all the axis. Now, in order to change the background, and then I wanted to have a grid on the background of the image. So for which you can use a method or the function called as a grid method on a plot object, plt.grid. Color parameter is equal to, I said just a white. Now you can see the white grids were formed on background image. This background is a gray, right? So the lines are solid. Now you can see. Okay. Now let us change it a little more so that we'll get a beautiful plotting. What I did is now I just wanted to remove the spines. You can see the borders. I'm talking about the X border and then Y axis along with the X axis and then Y axis. We have a solid line, right? So this looks very odd. So for which what I do is I'll just change it. Okay. So you can disable them by just removing it. Okay. You can just remove the spines by making invisible. So what I do is I'll navigate to each and every spine. There are 4 spines, right? By default, with the function called axis spine dot values will give you all 4 spines. So I'll navigate through the 4 spines and then set its visibility is a false. When I say set visible is a false, then what happened here? When I set visible is a false. If I say true, what happened? I'll get as the spines are visible. But whereas when I set this set visible is a false, then you can see all these X and Y axis borders called as the spines are now invisible. Okay, it looks now more aesthetic than the previous diagram, right? Now you can observe here. So what I did is I just also wanted to remove the tick marks. Here I have, you can see in the 4 dimensions, in the 4 directions, you can see up, down, and then left and right. I have the small markers called as the ticks. So I don't need these ticks also, except in the left side and then bottom. Okay, I don't need these ticks. So for which what I do is I'll just disable the top and right one, and I'll set ticks only the left side and then bottom. That too, this tick should be the outside of my spine, should not be inside like my default one. Okay. Isn't it? All right. Now, see, just a moment. Just a moment. Okay, now you can observe these borders. The spines are now invisible, and then even ticks on the top and right is also invisible. Okay. So for that, what you are supposed to do is you have to change the runtime configuration using a function called RC. For which what you have to do is first, as I told you, you have to save the default configuration into a variable so that you can use the same variable as in when you wanted to reset the configuration. So for that, what I do is I just took a variable called IPython default and then stored the default configuration by copying the default configuration with a function called copy. So for which you have a module called RC params called reconfiguration parameters, and then I am just copying all the set values, default set values into this a local variable. As and when I require, what I'll do is I'll just call it. Okay, so before I do any changes, before you do any changes, you have to copy the default settings. That's very much important.
Excuse me, sir.
Right. So when you wanted to have your own styles, then you can easily customize by just navigating to each and every color parameter. So these color parameters can be accessed from a module called as a cycler. Okay. So what you have to do is initially you have to import the corresponding module from the Matplotlib library, right? So you can observe here, I am just writing how you can import it. So you can from Matplotlib, you can import cycler. The cycler module will help you to access different functions to change the colors of the plot, right? So that's where the cycler a function will have a different parameters like color, grid. So basically the color. So it creates a cycling pattern using the cycler module. It cycles through a list of colors specified in a hexadecimal format, as I discussed. All right. So you can simply call RC, okay, runtime configuration function. plt.rc, and you can specify axis, face color. Okay, face color I gave is a grid, right? Edge colors I just said none. If you didn't mention, it will be black by default. Axis below is true. What is axis below? Along with the x-axis, I wanted to have ticks. Grid is true. If you say false, then what happened? The plain background will be applied. So I just wanted to have my grid so that I can easily identify my plotting positions or coordinates. Okay. And then I'm just using all these colors as I drawn the different multiple colors into an object called colors. Now I am passing that colors object to a property cycle. So this sets a various default properties for axes such as face color, edge color, isn't it? Whether the grid should be displayed or not is your wish. And the color cycle to be used for plotting can be chosen from the colors object. In addition to it, what you can do is this sets the default properties for grid lines, specifying their colors, right? Specifying their colors. Of course, you can also specify the line styles. What is the line style you wanted to follow? Dotted, solid, right? Or whatever you want, you can draw from the line styles which we have discussed in the previous class. Along with it, you can also mention what kind of tick you want. By default, you observe. So in a default diagram, what we observe is we have got these ticks inside the spines, right? So, but usually we don't see these ticks in the inside of the spines, but we wanted to have them in the outside of the spines. Could it be the x-axis or y-axis? It doesn't matter. But we wanted to have it in the outside of our image along with the x-axis and y-axis, and I wanted to disable the ticks in the top and right of the image. So anyhow, we set it. So see, by default, if you did it, then whichever the plot you use, so that will be automatically all these features will be applied automatically to that plotting. Okay, so I just use X tick. Direction is out. Now, if you say direction is in, the sticks will be visible in the inside of the image, right? Color, you can say the color by default we use a gray, but if you want any other color, you can use it. Okay. Now, if I run this code, now you can see more aesthetic plotting have come with the different colors and then features. Now in this histogram, you can see by default it was in a blue color. Now it looks in a, this color is not exactly the red or it's a different color. You can change whichever you want. I just remove the edges. You can see earlier the edges were in a black lines, but now there are no edges. Okay. So now ticks also you can observe. Ticks are outside. If you want, you can disable top and right side spine ticks. Right now we don't have any problems if they are not inside, and then there is no point of overlapping. And now, but by default, the simple line plot looks like with the runtime configuration parameter. By default, it is looks like this. If you wanted to change, you can change them. Now, so coming to the style sheets. So coming to the style sheets, the style sheets comes with the style module, which includes a number of new default style sheets. So if you wanted to change them, you can change them. But whereas you have to remember, you need to save them with the Matplotlib styles with the MPL styles extension. Okay. So if you don't create your own styles, then style sheets by default includes the styles what are available in the styles list. What are by default? See, initially what we set is a set class style is equal to the classic or C1 white grid. We have seen these two, right? So similar to that, there are many such styles available. Now let us see the first five. 538 is a one style. Then C1 pastel is another style. C1 wide grid, ggplot, grayscale, classic, and so on. Okay. If you wanted to set them, what we have used in the first line of the the code, it's a plt.style.use. We have used a style name. Could it be classic or C1 white grid, C1 pastel, okay, 538 more style or ggplot, whichever you want from the list, you can simply use it. All right. So let's create a function that will make two basic types of plotting. So both the histogram and the lines I wanted to plot at one go. So that's what I'm just defined a function called a hist and then lines, and I set the values to be drawn a range from 0 to 1. Okay, I just wanted to plot 1,000 samples on a histogram, range from 0 to 1 by default, 0 to 1. So every time, whenever I generate, every time I want the same values, for which you have to set the seed value. I just set the seed is a 0. You can use any value, that doesn't matter. So, but the seed, you all know, the seed will help us to generate the same set of values irrespective of the number of times you are calling a random function, isn't it? Right? I'm just drawing the subplots. I mean, calling the subplots 1, 2 is one row and two columns. Okay, so figure size is 11 by 4, 11 width and then 4 height. Okay, so since it is two columns, I just wanted to access them by using axis of 0 and axis of 1. Okay, you can see by default when I just call this. Yeah, I just reset it. You remembered we have changed all the features of this function. Okay, so all the functions. But now what I'm doing is I'm just resetting my original configuration. IPython default, where I just showed, I copied all the default styles or the default features of the runtime configuration into IPython underscore default variable. Now I'm just using rc params dot update function to reset my default runtime configuration. So I've got, see, all the features which I have made are now disabled. All these are the features, right? Which are the changes which I made for my aesthetic view. But now these are the default. Again, I got my original or the default settings for my runtime for my plotting. I just call the function which I defined is a hist underscore and underscore line is the name of the function which I defined here. So the same when I call now, because I reset the runtime configuration, I got all my basic features. Okay. So both, no, this is how we can plot different plots on the single image, right? Because I just defined what? One column, two rows. Okay, with each the size is what I said, 11 by 4. Now let us see the styles, how we can apply the different styles. It's very simple. We can use a function called as a context. You can simply change the context of a style by calling a context function and a style module, right? And you can pass whichever style you want from the styles. So now what I did is I in the context of the style 538, I just call the function just in the line. Now you can see there are little changes as per the 538 style. Now you can see ggplot. Now if I apply ggplot instead of in the context, if I use ggplot, then I got this color and then this view, the grid. I've got the grid is here now. Okay, and then lines are grid, are solid lines in the white color. Okay, so now I use the another one called as a BMH style. Okay, BMH style means Bayesian method for hacker style. So this style have a different the visualization feature. So now you can observe if I just use BMH as my the style, then the style is given like this. Okay. Now instead of it, now I use a dark background color. So when I use a dark background color, and then this, if I use this style, then I've got here dark background color. Okay. Now instead of it, now I am using grayscale. So if I pass the grayscale as my the style to context function, then my grayscale visualization looks like this. This is how these are the styles. Simply you can test it by passing on a simple histogram and then line graph, right? So, but this looks a little time consuming process to change the configuration of many visualization features. So, and you have to be very careful because these are all set default, right? When you make any changes, and you have to ensure you have to reset for a normal visualization. What there is a new library called as a Seaborn library, which comes with a many visualization features. Okay, so many visualization features. These all are loaded automatically when you import a Seaborn library into your working environment. Okay, a simple example is instead of I do changes, I normally you can see if I import Seaborn and if I call the same function, now you can observe I have got my all features back with the more aesthetic view. So this is what uh, the style sheets that you can use to change the visualization features of any plotting. And also this is how you can simply change the runtime configuration for changing the features of any plot, right?